Hey guys, so I want to share something real quick that's important. The connection between force and potential energy in a little more intricate detail. So we have the force equation, and obviously we're doing this with gravity potential energy, and we'll do it with other potential energies over the course of the year, which is why this is kind of universal right now. And then we have this, right? So what we see is something actually kind of remarkable. That because we added up, right, work delta PE, right, is negative work, which is uh, 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 force times change in distance. I'll use R for this one. Then what we get is, oh, and there's a negative sign there. Then what we get is this. So I'm simply going to divide by this on both sides. So divide by delta R, divide by delta R, right? Cancels over here, and I get force. I'm also going to divide by -1, bring that over here. Force then equals negative delta PE over delta R. Obviously, I could do delta X or delta X or delta Y or delta Z or delta D, right? Remember, those are all distance variables, right? Some distance. In this equation, we tend to use R because once again, it's radially symmetric. It's a spherical symmetry. So it's like we're usually thinking of a radius out from a planet or a star for gravity. So the force of gravity, right, is negative delta P over delta R. But turns out this is true regardless of what force we're dealing with. This is universal, right? This is independent of just gravity. So what I'm going to do is show that this concept applies to the equations that we have here. So these are the equations we want to be knowing, right? Obviously, little g equaling this is another one. Technically, you can say negative also because it's inward. But remember here, this is inward because this is a vector. But here, this is actually negative because this is a scalar. So the negative sign means two completely different things here. But we're going to see that on a graph, it doesn't matter. That if I graph FG versus R, get this. And if I graph, sorry, I want to fit both of them in here. If I graph FG versus R, I'm doing a poor job of straight lines. I encourage you guys to do better at that. I'm only doing it for brevity, and I think it still illustrates the point that this is 1 over R squared, and that this is, and it's negative, and that this is negative 1 over R, meaning that's the proportion, right? Force goes as, and here potential energy goes as, right? So they look almost the same. But what does this mean? I think all of you know what this means. In fact, I know all of you know what this means. As a concept, change in potential energy over change in R. Change in potential energy is rise. Change in R is run. We have rise over run. We have slope. So force in general is the negative slope of potential energy. This is the intimate connection between the two. This is how they are connected. This is the most important thing. To me, this is the most important thing. Realizing if you know the potential energy, you know the force. If you know the force, you know the potential energy, not just from the equation, but from this graphical visual concept that the rate at which potential energy changes in distance, careful, slope of potential energy with delta R, distance, not time. Acceleration is delta V over delta T, which is acceleration is the slope, positive slope, meaning is the slope of velocity with delta T time. Did I squeeze that in there? Oops. No, I'm sorry, that says time. So acceleration is the slope of velocity with respect to time. Force is the negative slope of potential energy with respect to distance. So these relationships are the two important relationships I want us to practice. And we're going to do practice questions where we graph them and we see this intricate relationship at play. And this helps us graph it more accurately. And graphing it more accurately helps us picture it and visualize it more accurately, which means we get a much more intricate analysis of what's happening. So I just want to look at these two general graphs. I just sort of graph them right here. Let's look at this. So what's the slope here, right? Large, I always do my hand like this, positive slope. So this has a large negative value. And those are connected. Pause and let that make sense. So if I have a large pause, so I'm going to ask you guys to go through these graphs really carefully. We're not moving fast for each question just to get an answer. We're sitting with it until we can like feel it, like feeling the tapestry of a Van Gogh painting, right? This three-dimensional landscape. We don't want to just sit, look at it, say, cool, those are haystacks, right? We want to like feel into the intricate dimensions of, oh my God, there's so much emotion and like intricate detail there and relationship that opens up the truth of existence. So that's what we're going to do. So a large positive slope here results in a large negative value here. Force is the negative slope of potential energy with respect to distance. So we can keep doing it here. Here, what happens? A smaller but positive slope. Here we have a smaller negative value. And we'll call this like R1, call this like R2. This will be R1, R2. Notice at the same position in space, here's the slope, here's the slope, here's the value, here's the value. Those are connected. Now you guys might be asking, what about other things, other things? Don't worry about that. There are probably other connections that might be firing off in your head that may be valid or may just be smoke and mirrors, meaning it looks like it has a connection, but it doesn't. This is so grounded. This is grounded in the work energy theorem. This is universal. And I want you to sit in this. I know, and I always encourage your brain. I always encourage you, everything you want to do. Your soul is called to looking for more connections. Go there. If other questions are coming to you, but also take a breath and integrate this. This is one of the most important relationships in physics because it applies to everything and it describes so many things. So I want us to be able to match these graphs. And if I give you a graph with a new force or a new potential energy in the future, we're going to apply this. So that's it. There we go. Take a breath. We're actually going to practice it next. See you in class.